Hey everybody, Cole here with Classic Mini DIY, and on today's episode we are going to be talking exclusively about the 16-valve twin-cam head and all the things that need to be done to it in order to prepare it for the Classic Mini's A-Series block. You won't want to miss it. Stay tuned for that. All right, folks, that's right. We are finally going to be answering the most asked question in the entire world, and that is, how do we take an early 2000s BMW motorbike head and put it onto a 55-year-old engine platform? I know the world has been waiting for years to learn the answer to this question, but don't worry, today I am going to show you guys, and I'm going to answer that question once and for all. Now, if you missed the kickoff episode for this build, make sure to head back and watch that. The short of it is we are taking a BMW motorbike head, which you can see in front of me here. This one is a K1200 RS, which is the kind of fancier version of this motorbike head. And we're going to modify this so that it can mount directly to an A-Series block and give us a number of really wonderful advances and improvements to our performance on the Classic Mini. And on top of all of that, we are going to be turbocharging it. We're going to be switching it to fuel injection. We are going to go to drive-by-wire. It is going to be an amazing engine. But on today's episode, I want to show you guys everything that you have to do to this cylinder head to make it work for your A-Series block. But before we get started on that, I do want to share that we are currently raffling off my Bad Wolf turbo engine. That's right, anybody in the world can grab a raffle ticket and enter in to win the entire engine, gearbox, turbo, hot side, everything, the whole lump, ready to plop into your Classic Mini and start ripping down the road with some serious power. But once those tickets sell out, we are going to do a drawing, and one lucky winner is going to win that entire engine and $1,500 to help them ship it anywhere in the world so that they can use it on their car. Anyways, let's get over to this head. I want to show you guys a few things about this cylinder head that we're going to have to change and things we got to do in order to mount this directly to an A-Series. Now, as y'all can see here, this is a 16-valve head. We talked about this a little bit in the last episode. Get a little bit more light on that. And you can see there are a number of waterways all across the block, oil channels, oil drains down here on the bottom, and just a bunch of holes on the bottom of the cylinder head. Now, there are a number of ways that you can approach this modification to prepare this for the block face itself. One option is to go through here and fill the necessary holes in order to block the waterways or block the oil channels where it's necessary and match it up to the engine block. Or you can fill holes on the engine block side so that you're not getting water coming through in certain areas. Or in my case, what I'm going to be doing is a combination of both of those. I'm going to be using a special head gasket that's going to block some of these channels on the head, as well as block some of the ports on the engine block itself. But there are some welding modifications that we still have to do to the cylinder head in order to make it work. Now, the first ones you might notice are these drain holes on the bottom. This is where oil drained out of the cylinder head from the factory. And I'm going to pop up on the screen real quick. This cylinder head actually didn't sit the way that you might think it would from the factory on a motorbike. It was actually a little tilted. And so these drains were at the bottom of that tilt, allowing the oil to come running out of these holes pretty easily. For those of you who are familiar with the A-Series block, you probably know that there's nothing like this on the block, which will allow oil to drain back down into the sump. So we do need to modify these in order to make it work properly. Now, the easiest way to do that is with the bag sport kit, and I'm going to pop this on its back, and let's have a look at the top side of the engine. So with the bag sport kit, it's going to come with a few pieces of cut aluminum. This is laser cut aluminum, which is going to be used to fillet and fill in some of these holes. So we will take these two pieces, do a little bit of manual filing down of this material on the edges, and then this gets welded in. It gets TIG welded in all the way around, getting nice penetration into the cylinder head itself, and then you'll have your machine shop surface this back down flat so that these don't protrude any. Once that's done, you actually drill and tap these for 2 hose fittings that will then run down the backside of your engine when it's in the car and allow that oil to drain back down into the fuel pump hole, which is originally used on the A-series block on the backside. Number 2 is another bit of specialized welding and machining needed. So this face right here is the face that you probably have seen in really cool photos of TwinCam engines with their big pulleys and the belt that runs all down, and there's a bunch of tensioners and everything. That's how this cylinder head is also going to get set up. Similar to the way the head sat originally from the factory, this is a full open chamber full of oil, and it actually used to be covered by both the valve cover as well as a cover that goes on the side here that attaches it down to the transmission. In our setup, we don't have that, and so we have to create an oil-tight situation here. So we have yet another piece of laser cut aluminum here, and this little fillet strip goes right in here and creates another surfaced face here and here to fill this in. So you weld all the way along this line here, you weld on the inside here along these edges, and then you have your machine shop do the exact same thing that they were doing before, which is decking the head. And that's when the pieces here that were drilled and tapped previously will get machined flat, and then over here gets machined flat this way as well as this way. This is what's really, this part right here is part of what makes it so important, and let me show you why. So you guys can see, this is going to give you a little bit better illustration of what I mean. This is going to, let's flip this on its side. So the new end cover will go on something like this, but you guys can probably see just from looking at this right here where this big gap is open. So that's what the fillet is filling. This will sit on the face of your block, but you do need it to seal, and then you have 2 screws going right through here that will get drilled and tapped into that new fillet piece, which is why this is so thick. This gives you enough face on this side right here to really get a nice bite in those screws and get a nice thread in them. But that's a good idea of what I'm talking about. A fully machined flat face right here for this new plate to mount against. The next thing I want to talk about are the mods that are required on this side. Now, depending on the model cylinder head you have, if you have one of the 8 valves or if you have an LT or an RS, there are differences between all of them. And in fairness, I am not an encyclopedic knowledge on the differences. But in my case, I have an RS head, and there's some additional holes here. And then on all of them, there will be a post that sticks out to approximately right there. That post is used for a factory tensioner where you'd have the cam gears sitting in this enclosed area, and this whole space is obviously open to oil. In the new setup, you get a plate like this. This is a 3D printed one, just for clarity. And you have your new cam pulleys that sit outside of that oil space. So you need to cut this post down, and then you weld up around it, because this post is actually open into the water jacket of the cylinder head. And so as we modify it, as the head contracts and expands with heat and cool, sometimes this can come loose and then allow water to pass by and contaminate your oil. So the recommendation is to weld around this right here, get a nice full welded seal. Then these 2 holes right here, the top one you can see is an oil channel. This is what feeds oil into these parts of the camshafts. This I would recommend filling as well. This will seal this off so you can keep oil pressure up inside this channel rather than leaking out into this chamber and just kind of draining back into the engine. My hypothesis here is that if you seal this, it's just going to keep that oil pressure high in the cams and keep the oil pressure higher so you don't lose anything there. And then this threaded hole, while it doesn't appear to go into the water jacket or anything like that, this is not used. So while we're here on the LT heads, it looks like neither of these are here. There's no hole here and there's no thread here. So I'm going to match that when I have it at the machine shop. And that's just about all the modifications on this side of the head. One more time, I do want to show you, this is how this fillet goes in here, approximately like that. We'll get welded in, and then this gets machined flat, just like that. Okay, so moving on to the exhaust side of the cylinder head. So this side of the head doesn't require a ton of modification. The only thing that gets changed up, and with the bag sport kit specifically, the way that it's built is to use a head gasket that blocks all of the channels between the cylinder head and the block that are necessary. And so you have to feed oil to the cylinder head a different way. And we do that via this hole on the back here. This gets tapped at the size that you see on the top of the cylinder head. That hole will get drilled, tapped, and then you'll attach a small AN line on the back here and feed the oil directly into that hole from a pressurized port on the block. Now, continuing our walk around the cylinder head here, the next thing that we're going to talk about is how we are going to cool the cylinder head. Now, some of you have probably seen a version of A-series blocks and A-series heads using something called a dry deck system, which you should see popping up on the screen right now. This is the same principle that's going to be applied to this K-series head. And this end, which as a reminder is the end that is facing your clutch. So you're right below here is your transfer gears and the clutch housing. This right here is where the water jacket is. So you can see these freeze plugs, core plugs, frost plugs, whatever you want to call them. These plugs right here on the top, this is your oil channels. So oil is draining down into this upper channel. And then here is your water channel. So normally this right here would have a coolant temperature sensor. What we're going to do is weld this hole shut, and then we're going to take a aluminum end here, and this is 1.25 inches in size, and we're going to drill a new hole, and then this gets welded in place. And that is going to be your dry deck feed from your engine block up into the cylinder head. The cool thing about this is because we are channeling that coolant from the block directly into the head, it is going to pass along the entire cylinder head, creating an incredibly uniform cooling process. This is the main reason people dry deck their A-series engines, because in the factory setup, you have holes that run across your whole block and your whole head, and water will take the path of least resistance to get back up into the cylinder head and then go through your thermostat and out to the engine again, into your water pump. So people will dry deck their cylinder heads to force that coolant to come over here and then pass across all of the cylinders. Because if you don't do that, cylinder 4 and 3, but specifically cylinder 4, tends to be much hotter than the rest of the cylinders on a factory setup. And that's because coolant is going up into the first holes, around 1, 2, and 3, and then going back before it gets over here. And the coolant that's over here is circulating at a much lower rate, so you're getting a hot spot in that cylinder. As we're turbocharging this engine and doing performance modifications, pushing the timing much farther, we want those cylinders to stay as cool as they possibly can, and that's why we're going to dry deck this. This also provides a much easier configuration, especially for these K-series heads. Now moving on to the last bit of modification that I want to talk about before this gets mailed off to the cylinder head shop, and that is oil drains. Now you can kind of see here, it is a little bit difficult. I have it on its side here just so you guys can see it a little bit better, but you're looking at the top of the cylinder head, or what will be the top on the A-series setup, and you can see, and now you should be able to see there are cast holes across the cylinder head, and I'm going to be highlighting those for you. Those holes are where oil drains down into that channel and then will go back down to the drains that are on the bottom of the cylinder head. However, there is a bit of an issue with these K-series modifications because of the new orientation of the head. Be more like a traditional automotive head, and that is oil will sometimes pool specifically in this part, this chamber right here. When in its OEM configuration, this was tilted, so oil can pass more easily around these camshaft channels, specifically around the tops and the bottoms. When it's fully upright, it takes a little bit longer for that oil to get up there, which means that when the oil pressure is super high, it can pool here sometimes. Some people will put drains on the ends of these, which we will have, but I also am going to be drilling a small hole right here that is going down into the channel below it. Now, this is something that I guess is a little bit controversial. Some people don't like drilling holes like that in cylinder heads. And I think I understand that, reservation. However, these are readily accessible for me here in the States. And I stuck a little borescope down in this hole to confirm there is some opening in a channel over here. So I think it's going to be a good opportunity for me to prevent this issue going forward. So I'm going to flip this back upright. We're going to drill a hole, and I'm going to show you guys what it looks like when it's done. Now I was trying to find the best way to show you guys how this hole was drilled. And what you can see here, this part right here, this is a cylinder head mounting recess, and it's where your studs go through. I drilled offset from that hole, and this right here is that same thing. So this is the top, this is the side of that same part. Right here is the spring, which you can see is underneath this channel here. And I did about a 5.5 millimeter drill bit and ran it just down in there, and you can see right down into that space. And so we obviously need to get those shavings out of there, which likely I'll have the machine shop do when they're cleaning everything out. But this is going to allow that oil to fall back down into this oil channel, which will then allow it to drain back out in that direction. Makes me feel a little bit better. In reality, it probably was fine, probably didn't need much. But one more thing that kind of sets it up for success, and you don't have to think about it. All right, so that kind of wraps up all of the cylinder head modifications that have to take place in order to make this compatible with the A-series block. The block itself also requires modification, and I'm going to show you guys all those changes once that gets here from the UK. I actually bought an A+ block local in the UK. It ended up being a little bit easier to source a 1275 there, and shipping a 1275 isn't too bad when you ship it from the UK to the US. So before this heads off to the machine shop, which has a little bit of a waiting period, it's the winter here, so everybody has all of their car projects sent to the machine shops around Charlotte, and there are not a lot of them anymore. And the one I'm sending my stuff to is called MBE. They are well known here in Charlotte as one of the best cylinder head shops that you can get work like this done. He did the specialized work on the 1100 head to some really specific specifications that I gave him, and he's going to be doing all of the head work on this cylinder head. And we probably won't see that back until late January or February. So lots of waiting, but that is also kind of the name of building an engine like this. You got to send stuff off, get it prepped, get it done right. You get it back, then you got to do it again. So it's all how it goes. But you guys can probably see here, I have a prototype of the intake plenum that's going to be used on this cylinder head. And like I said before, I'm going to be building a fuel-injected drive-by-wire turbocharged 16-valve engine. And in order to do this, you need a few sensors, you need a few injectors, and you need a mounting flange for your drive-by-wire throttle body. So that is where this plenum comes in. This is a custom plenum. This is obviously a 3D print that is made by Bagsport. That's part of the kit that I'm going to be installing on this car. It sits on the front of the cylinder head, roughly like so, and will capture all of the air, firing an injector into each individual cylinder. So we're going to have really fine-tooth control over the fueling. And then the drive-by-wire throttle body, similar to the ones on the kits that I sell for the 5-port engine, will go right here on the side of this plenum. And those throttle bodies are actually made by Bosch. So really well-known parts producer and really reliable setup. Mounts right here. And then on the bottom of this plenum, you have a few takeoffs for things like your rising rate fuel pressure regulator, your MAP sensor, your blow-off valve, and any other sensors that you want to take off and read from the manifold pressure. So very, very cool. And if you can believe it, this is all going to fit with no body modifications to a round nose Mini. Pretty cool. It's a very, very tight setup, a very, very well thought out and designed setup, and it will have a custom billet fuel rail that runs across the top to deliver fuel to all of those injectors. So anyways, I wanted to show you just a little sneak peek of that. Very, very cool. But if you guys have any questions about this setup, about the modifications I did, Or maybe you have some feedback that you'd like to share with me. Or maybe I missed something. I've been doing a ton of reading to try and learn everything there is about these K-series heads, but this is all a new process for me. I've never worked on a head that is a little bit more modern than the 5-port setup, and I've never worked on a TwinCam head. So lots of cool stuff to come, but I appreciate you guys tuning in. And don't forget, the raffle is running for my old engine coming out of Bad Wolf, which will be replaced by this, and that is a 200 horsepower turbocharged drive-by-wire setup on a 5-port head. So very, very nice setup. Grab your tickets while you can. And that's going to wrap up this episode. So thanks again. And until I see you on the next one, you know the drill. Enjoy those minis and motor on. See you guys.